Scott's Geography Notebook. Did you want to try saying it?
Da, da, da.
We're going to need to combine a few different ideas in order to understand this principle of dew point temperature. So we're going to bring some of those together, and in this we're going to call it How Do You Do? All right, so here's what we know so far. We know that as air rises, it gets colder. We talked about this in a previous presentation in that we were talking about how as an air parcel goes up, it has room to expand and it goes higher and higher and higher. We call this our adiabatic rate. And we talked about how if our relative humidity is low, then that dry adiabatic rate is going to be negative 10 degrees Celsius per 1,000 meters. Perfect. As an air parcel comes back down, it warms by compression, and we can talk a little bit more about that in another presentation. Okay, so our air is getting colder. Now, the other thing that we know is about relative humidity. And our relative humidity is actually a function of temperature. Okay, and so what do we get from this? We know that our relative humidity is equal to this actual amount of water vapor that's in the air. We refer to that as our specific humidity. That is compared to the total holding capacity. And this total holding capacity is how much water vapor that air parcel can hold. We know that warm air holds more. Warm air holds more. And cold air holds less. Right? And so if this number, if our air parcel's going up, our temperature is getting colder, that means that this total holding capacity is becoming smaller and smaller and smaller. If you decrease the denominator, then what happens is with both of these ideas together, as air rises, it gets colder. Relative humidity increases until it gets higher and higher and higher, and eventually relative humidity becomes equal to 100%. Okay? Now, this is all based on the temperature. And so the temperature where this happens is referred to as the dew point temperature. Okay, so let's think a little bit deeper about this dew point temperature. If we were a little sarcastic, and we are sometimes, as the temperature at which point dew forms. Get it? Temperature at which point dew forms. But there's a lot that goes into this. So one of the things that we just talked about was this relationship that we have between our relative humidity and our dew point temperature. Because we know that at dew point temperature, relative humidity is equal to 100%. In other words, at dew point temperature, specific humidity becomes equal to the total holding capacity. Right? We call our air parcel at dew point temperature saturated. Now, there is, as an air parcel continues to rise, an elevation, because as our air parcel goes higher and higher and higher, it gets colder and colder and colder until it reaches that temperature when it's going to be the same as the total holding capacity. That altitude where we reach the dew point temperature is referred to as the lifting condensation level. So we would say that this is reached at that lifting condensation level. And if we needed to define that lifting condensation level, it would be the altitude where an air parcel reaches 100% relative humidity. Or, right, that's going to be our humidity, or dP, dew point, dP temp. Okay, so there is an altitude associated with all of this as well. So the altitude is going to be that lifting condensation level. The temperature is going to be the dew point temperature. The relative humidity is going to be equal to 100. Now, at this spot, there's a few other things that are going to be taking place that we can actually see. Some visible things that are going to be happening. Another one of those things that we're going to be able to see happening is that water vapor begins to change phase. See, the air parcel isn't able to hold that moisture anymore. Okay? It's already reached its 100% relative humidity. And because it's at its 100% relative humidity, it can't hold any more water vapor. So water vapor is converts to water droplets, or water vapor condenses to droplets. Okay. Now, this guy right here is a phase change of water. And I should say water vapor begins to condense. Water vapor begins to condense to droplets. Okay, now what do those droplets look like? Okay, now we'll come back to this idea of the phase change of water in another video. But what do those droplets start to look like? Well, those droplets start to look like clouds. So if you were outside on a beautiful day like today, and you saw this lovely puffy cloud that was out there in the sky, and maybe the one that you see has that nice flat bottom along the bottom, that cloud right there is going to be my air parcel. Okay? My air parcel has reached, it's gotten cold enough that now the temperature is the dew point temperature. It's reached a relative humidity of 100%. That altitude where that has happened is my LCL, or my lifting condensation level. Okay, so we have my altitude, we have my temperature is equal to the dew point temperature, relative humidity is equal to 100%, and now clouds begin to form. Droplets begin to form up there. And that's referred to as a cloud.